Okay, here we go in our week 7 3D scene series. Today we're going to be introducing 3 aspects of processing 3D that are actually, I think, more intuitive than maybe some of the other stuff we've seen with the ideas of navigation and cameras and translation, rotation. They're going to be more like kind of on the aesthetic side. Like we're going to be dealing with how can we take a geometry and wrap an image around it like a texture? How can we bring in other 3D files that maybe either you've created or that you can find on the internet into our scene? And then also how are we going to deal with lighting, which is actually a very cool and one of my favorite topics in computer graphics and especially in 3D. And so the first thing we're going to do today is we're going to take our sketch that we had from the previous lecture where we had our 3D particle system inside the box. And we're basically going to use that as our starting point, and just add a few things to it and actually take off a few things too, just to make it a bit more clear. So we're going to start with texture wrapping a geometry. We're going to add an external geometry, a .obj file. And finally, we're going to talk about lighting in 3D. So why don't we go ahead and jump into that. Okay, so here's our sketch from last time, week 7, class 1B. What I'm going to do is going to go File, Save As, and I'm going to save this as 1C. Great. Now what I'm going to do is I'm going to hit Command K, which opens up over here the folder where this lives in. You could have also gone to File or Sketch, Show Sketch folder. There we go. And you need to make sure that you have the data folder that you'll download from the resources that has our OBJ file and our JPEG that we're going to use to map onto a geometry. So we're going to use this kind of ice texture to put that onto a box, and we're going to use this kind of mildly horrifying human hand skeleton to import that into our 3D scene. Okay, great. So once that's there, you should be good to go. All right, so first things first, let's start with creating the geometry that we want to be wrapping our texture to. So what we're going to do is maybe consolidate this a little bit. So we need to add a P shape. We've seen that before, I believe. Yes, with our .svg files. So we're going to do that, and because we're going to have a box that we're going to wrap that ice texture onto, let's call it Icebox, just to kind of keep it clear. We're also going to need a P image that I'll just call image, and this will be the actual ice image that we're going to map onto our Icebox. Okay, great. Now we need to actually load those files into the variables, which we will do in our setup loop like we've done before with load image and all that good stuff. So first things first, image. We want to use that ice image that we saw. So we're going to say image equals load image. Ice.jpg was the file name. So load image to use as texture. Okay, great. Now we're going to see a slightly different way that we can create our box. So instead of just saying box, we can also go this way, and this is what we need to do if we want to use a texture on our geometry. We can say that Icebox is going to equal create shape. Okay, so what kind of shape do we want? Well, we want a box. Turns green, that's a good sign. And just like how box normally needs to know what the dimension is, we can just put one number, which will mean that our box will be a perfect cube 100 by 100 by 100. So this is very similar to saying box 100, but in this case, because we're using this create shape method, we can now do the texture aspects as well. So what I'm going to say is I want to use our image as a texture to wrap onto our icebox. Think about it kind of like if you were wrapping a present, right? Like you're going to take some 2D piece of paper that has some image on it, maybe like snowman or whatever, and you're going to wrap it around the box. That's exactly what we're doing, but just in pixels. And so what we can say is icebox dot set texture. And now what is the image that we want to use for the texture? We want to use our image. So wrap icebox with image. Okay. So that is now good to go. So now we actually need to draw this icebox to see it. Now let's keep consistent with how we've been using our scene and our nav functions. So I'm going to go into our scene, and now what we need to do is draw our icebox. So what I'm going to say here is shape, because that's what we do for p-shape. What's the shape that I want to draw? I want to draw our icebox 0, 0. Okay. Now, one thing I want to do before we run this is I'm going to comment out, I should say, the part of our particle where we're actually adding the movement to it, where we're adding speed, mainly because we're going to be focusing on textures and importing objects and lights. And I think that this will just kind of distract us from what we really want to look at today. So we're still going to be generating all these particles, but they're just going to be stationary. They're just going to stay put at whatever their initial X, Y, and Z position is. Okay, so now we're drawing our icebox. Let's see what we got. Okay, great. So we can see now that we have this, well, first of all, it's kind of cool, right? We have our stationary particles, which kind of look interesting to me. But now we have this box that looked like our other boxes we created, but we've now wrapped this ice image onto the surface of it. Now, what's kind of cool about this is if we zoom in, we can actually go inside the box, and it's that same image is wrapped on the inside as well. And we also notice that we have two little particles hanging out here with us. That's kind of cool. Okay, so this is kind of interesting because you can imagine now that you might make a really big box or maybe a really big scene, and all of a sudden you've now created basically an environment to have your 3D scene live inside of. So you could get creative with that. You could choose your images such that you kind of create like, oh, I don't know, an underwater scene or maybe a space scene, right? Or whatever you want to do. Maybe it's more abstract than that. Maybe it's like a really nice color gradient that is giving the sense of some environment that we're inside of. A little bit like Matrix vibes going on here, like we're inside this artificial space. That might be the second Matrix reference I've used in this class this year, so either sorry about that if you're not into it, or you're welcome if you are. But you can imagine now having an image textured onto a geometry, and then now you're creating kind of a sense of a scene. So you could do this to spheres as well. They behave slightly differently, like mapping a flat 2D image to a flat 2D surface, is probably a bit more true to the image than onto a round surface, but you can actually get some really cool effects out of that too. One thing to note is if you're wrapping your image to a sphere, is you probably want to turn off probably want to do no stroke, because otherwise you're going to see a bunch of those triangles that make up your sphere. So it's just something to note. Okay. Oh, by the way, for PZCam, if you double click, it brings you back to the initial camera position. There you go. All right, great. So there is our icebox. Let us now turn our attention to importing external 3D files into our scene. So we have this creepy hand that we're going to be using today. So let's go ahead and get that imported into our scene. So we're going to come back to our main tab. And now we want another P shape. And let's call it hand. And now, just like our other shape, we need, or like our image, we need to load our file. So let's do that right here. So what we're going to say is hand equals load shape. And the file we want to load is hand.obj. OBJ is a common 3D geometry file. So if you are searching online to get other files to use in your scene, make sure you're looking for OBJs. There might be a library in processing that you could also do another common file in STL, but by and large, I think it's maybe best to stick with OBJs. Also, on the other side of the coin, if you're creating your own geometries, like in a program maybe like Blender or Maya or Rhino, Fusion 360, there's a whole bunch of 3D software out there to create 3D images or 3D objects. Probably want to export your object as an OBJ if you want to use it. Okay, so now that that is loaded, we are going to, instead of just drawing one of them like we did with our icebox, what I kind of want to do is I wanted to have our particle actually be the hand, which will be mildly terrifying, but it'll just be nice to see how we can use external geometries as our particle. So what I'm going to do inside of our particle here is, instead of drawing a point, I'm going to use our hand instead. So let me just comment this out. Okay. And in fact, we're not going to have a stroke or a stroke size anymore, so I'm just going to comment all those things out. So now our hand is going to be our actual particle. So one thing that we need to note before we get into that is if I were to just put our hand in, well, let's see what happens. So what I'm going to do is put hand, sorry, not hand, shape, and I'm going to say hand, and I'm going to put it at 0, 0, 0. It doesn't like, oh, so for shape we only give it 2 parameters. There we go. Okay. Now we're not really seeing anything. So why is that? Well, the problem is a couple things. Now that we're dealing with shape and an external OBJ file, we don't really know, like we currently don't really know the size of this hand, right? Like before we had stroke weight, which was our size for our point, but we don't really know exactly what the size of our hand is. You can get a clue by seeing how big the file for this .obj is. Like if a file's like on the order of like megabytes, it's probably a very big file. And so we just have to be we'll kind of have to play around and tweak these things a bit to get them to be the right size. But also, because we're going to be scaling this, so let me kind of come from the other way and say that our hand right now is way too big. And I'm sorry, but way too small, which is why we weren't seeing it. So I need to scale this up. So what I'm going to end up doing is say scale. And I happen to know that this file is so tiny that I need to scale it up 20 times for us to see it more clearly. Now, here is the very important part. Remember that anytime we're using translation, rotation, or scale, we want to make sure that we're using our push and pop matrix to only apply the scale just to shape, because otherwise we're going to be scaling everything in our entire 3D scene, which is not what we want to do. So I'm going to go ahead and put up our boundaries, push matrix, pop matrix. Okay. And then the other thing, because we're drawing hand at 0, 0, we need to make sure we're actually using our X, Y, and Z location. So we're going to be doing a translation as well. Translation, X, Y, Z. So now what's happening? Translation. Oh, translate. Translate. So now what we're doing is we're still using our random X, Y, Z variables that our particle has. But now what we're saying is, okay, isolate our hand with our push and pop matrix. Go to the X, Y, and Z location, translate there, scale the hand up by 20, and then draw it at that location. So now when we run this, we should see all of our hands. And there they are. Okay. So again, a little creepy, but you know, here we are. So, okay, so in your scenes, if you're bringing in external geometries and you're not seeing them, kind of first step is make sure you're putting them somewhere where you expect them. So by translating it to some known location. And then also you might need to do some scaling so that you see it correctly. Sometimes you're going to get a really big image file and maybe everything will turn gray. And that's because just like how we were sometimes inside of this geometry, you might be sort of inside your OBJ file, in which case you need to scale it down by a lot. So maybe by like, 0.1 or something like that. All right, so just something good to know. Okay, so that is our second item of the day. How can we use a 3D geometry that is made outside of processing, like a .obj file, and bring it into processing? Great. Okay, so let's talk about our final topic of the day, which is lighting. Okay, so before we get into lighting, we're going to demo a handful of different types of lightings in this scene. It kind of helps to have the background, just for demonstration purposes, be black. Just it helps to see the colors a bit more easily. So I'm just going to change the background to black. Okay, so let's switch over to the other screen and talk about light for a minute. Okay, so processing has a couple different types of light. And the way I like to think about them is to imagine kind of a stage, like a theater, and then show how each type of light is kind of like a type of light you would see in the theater. So let me draw that if I can. So here's our stage. Maybe we have, our curtain. This is our red velvet curtain, very crucial to this demonstration. Okay, so here's our stage. Now, let's think about the different types of light. So the first type of light we're going to see is called ambient light. And this is basically kind of what it sounds like. It's just sort of like light that doesn't have really a specific location or a specific origin. Like you can imagine the opposite might be like a spotlight where it's a particular place in space and you're pointing the light somewhere. Ambient light is just light that fills up the entire scene. So it has no location, it has no origin. And so when we see that in processing, ambient light, that's the function. All we have to tell it is a color. So we just have to give it an R, a G, and a B value. So that's our first lighting type. Okay. Now for our second light type. So let me say that if we were to use an ambient light, everything in this theater stage would be treated with that light regardless of position or direction. It's just everywhere. Okay. Now let's talk about directional light, which is the second type. Directional light. Okay, and we're going to see what we need to make that in just a second. But first, we need to talk about a way to think about direction that we haven't seen before in 3D. So here is our 3D axis, right? So we have X, Y, and Z. Okay, so one way that direction is used in 3D often, especially in computer graphics, is a little bit odd at first. But instead of thinking about it as like numbers in terms of 300 pixels in the X direction or negative 300 pixels in the X direction, we can represent direction by 0, +1, or -1. Now, what on earth does that mean? So it basically means that positive X is 1, and negative, and then on the other side of the X spectrum is -1. Same with Y, where we have 1 and -1, and Z, we have 1 and -1. Okay, so let's put this into practice and it'll make a bit more sense. So let's say that we wanted to have a directional light that was, on our stage right here. Let's say that this was, that's more like a camera, but let's say that this is our light. So if we were to kind of imagine our stage as this 3D space, our light currently is pointing kind of towards this negative direction. So it's kind of like having it here and pointing that way. Okay, so in order to represent that in code, we need to give the direction of the light in terms of this scheme of 1s and -1s and 0s. So if our light is pointing towards negative x's, so over here, what we're saying is that the direction of our light is towards -1 for x. So directional light takes a color, first of all, just like ambient light, we have RGB, so that's the color. But now because our light now has a direction, it's pointing at something, we need to represent that direction in code. And so this particular light that we just said, which was pointing directly into the negative x direction, we say that that has -1 for x, and we can say that it's actually just 0 and 0 for the other directions, because it's not pointing up at all or down at all, which would be +1 for y, -1, and it's not pointing on either way along the z-axis either. It's not pointing positive z or negative z. It's only looking straight at the negative x's. So that's why we say -1. This is x, y, z. We have a -1. We have and then 0, 0 for the other directions. So that's what this light is doing. Let's take another example. Let's say we wanted a light that was just pointing like straight at our faces, let's say. So let's say the light was here and it's pointing straight at the camera or the audience. Well, in that case, we're not looking in either direction on the X, we're not looking at either direction on the Y, but we're looking at the positive Z's. So we have +1 for the Z direction. Okay, we'll do this in code and we'll look at it, the result of that light, and hopefully it'll make more sense. But just know that direction is based on, are we looking at the +1 or -1 of that axis, or are we not looking at that axis at all, in which case it's 0. So to make a directional light, we need to tell it the color, and then we need to tell the direction we're looking at. Okay. Now, let me get a little bit of room here. Our third type of light is going to be a spotlight. Spotlight. Now this takes even more arguments. So these lights get more and more complex as you go. And so a spotlight is very similar to a directional light. If you just think about it, right? Like, okay, a spotlight points at something. The difference between a spotlight and a directional light is that the spotlight also has a location of where it's starting at. So, in this case of our theater, we had the directional light that was just kind of uniformly throwing light at the negative X direction, or uniformly throwing light at the positive Z direction out towards us. But we didn't have to set up any location for where that directional light starts from. Think about an actual spotlight on a stage. That might be hung up on like some catwalk or something like that. So here's our spotlight, and you think about someone singing or doing stand-up or something. There's a spotlight on them. It's coming from some specific point, and it's aiming at them. And it also has a certain radius, right? Like, how big is the spotlight? Is it really big, showing a bunch of people, or is it a really tight spotlight that's like just showing one person? So these are the parameters that we can play with spotlights in processing. So first thing we need for a spotlight is the color again. So we have RGB. The second thing for the spotlight is the location XYZ of the origin of that spotlight. So for example, let's say that our spotlight was going to start along the x-axis. So maybe our spotlight is going to start over here. Let's say 300 pixels negative x. And it's going to be, we don't know where it's pointing at, but we'll deal with that in a second. So we need an x, y, and z location for our spotlight, the origin of that light, in which case that would be something like negative, I think we said 300, 0, 0. So it's 0, 0 on the y and the z axis, but it's moved over negative 300 on x. So that's the origin of our light. So that's the next parameter of spotlight. Spotlight's the most complicated one we'll see. So if this one's a little bit scary, play around with it, but also know that there's other good lights to work with. Okay. Now, so we have our color for spotlight. We have the origin of it. It's fixed somewhere. Now, just like directional light, we need to know the direction it's pointing in. So we set up our spotlight to be on the negative x by 300. So we said we're going to start negative 300. So maybe it would make sense to have it pointing back towards the positive x. So the next thing would be, for example, 1, 0, 0. So that's pointing to the positive x direction and not pointing in either direction of z or y. Okay. Now the next one deals with the rotation of that spotlight. This one, I don't want to go too in depth with this. I tend to just put as a default radians 90 degrees. You can mess around with that, just see what happens when you put different numbers, but it deals with how that spotlight is rotating. I'm going to leave you to explore that part because it's not very crucial for what we're doing today. Now the final thing, which is a bit more crucial, is this last number, which we're going to put in 10 sort of arbitrarily, but the last argument for spotlight is how big do we want that spotlight to be? Do we want it really tight where it's just focusing on a person or maybe one part of our 3D scene? Or do we want a spotlight that's really, really wide? And so that, well, let's call that the, maybe the radius of our spotlight. How big is it? Okay, again, we're going to put this into code in a second and we'll see exactly how this works. But let's just talk about our last light here, which is, I'll put it over here. So the last light is our point light. And I like this one a lot, point light. Now, what does the point light take? It only takes two things, which is nice. So point light, you can think about it being like, so ambient light was everywhere, right? It had no source, no location. It just kind of ambient. It was everywhere. A point light is sort of like having a floor lamp or like a lamp on your end table or something, where it goes out in ambient direction. There's no like, it's not aimed at anything. It just goes out anywhere, but it does have a starting position. So like your floor lamp has a particular location in space, but it emits light everywhere, like an ambient light. So what we do for point light is we just tell it the color again. So we need to know the RGB. And now we just need to know the location of this point light. So maybe it's at, you know, who knows, like whatever the X, Y, and Z coordinate we want of that light. So it could be like 100 in the X direction, -50 in the Y direction, and 10 in the Z direction. Anything you want. Okay, so those are our four lights. So that would be, our point light would be maybe like a floor lamp that's kind of emitting light in all directions on our stage. Okay, so ambient light, a directional light, a spotlight, and then our point light. Let's set up each of these one after another in our scene and see how they actually get used in code. Okay. So if you remember, I have turned our background to 0. It just helps see the light a little bit better. Now what I'm going to do so that we can turn on and off our spotlight, or our lights in general, is I'm going to put all of our light stuff, just for demonstration purposes, into a mouse pressed, so that I can toggle the light on and off when I press the mouse. All right, so let's start with ambient light. So to make an ambient light, I just use the function ambient light. And if you remember, the ambient light only needs color. It's everywhere, so you don't have to worry about direction or location. It just needs color. So why don't we say that we want our ambient light to be red. We're just dealing with RGB. So just needs color. In this case, RGB could be HSB, whichever color mode you're in. But let's see that. Okay, so I'm going to click, and there we go. Now everything in our scene has this ambient red light to it. I let go, and there goes the light, comes back again. We can't see our boundary box, there it is, because that stroke was black, and now our scene is black. But we can see that when I'm holding my mouse and spinning our camera here, everything has an even amount of red light. It's ambient, it's everywhere. Okay. makes the scene even creepier. I'm gonna go ahead and go back to our box and make the stroke white, because this is kind of a nice reference to have our boundary for when we start talking about directions. I'm just making this white just so we can see it with our black background. Okay, let's come back here. All right, so that was our ambient light. Now let's talk about our direction light. So directional. So to make a directional light, you guessed it, directional light. Okay, so now we decided that we needed both the color and the direction we want to be pointing this light in. So let's start with color. Why don't we say that we want a green light. So 0, 255, 0. And now we need the direction. So remember, whichever direction we point into is represented by a +1 or -1, or if it's not pointing in that direction, a 0. So let's say that I wanted to point my light to the -x direction. So I'm going to say -1 for x, 0, 0. So we see needs color and direction. I'm getting an error. Why am I getting an error? Oh, forgot a comma. There we go. All right, let's check out this light now. Okay, here's our scene. Now I'm going to click. We can see some green light. It's not even though anymore, right? Like we're seeing on the left side a bit more green, on the right side a little less green. Let's slowly turn this so that we're looking in the -x direction. Aha, there we go. So now we can see that this directional light is pointing into the -x direction. So we are currently looking at the -x direction, which is why this face of the ice cube is completely green, but the other ones aren't. We're not pointing into the z direction. -z is what we're looking at now. Now we're looking at -x. And we're definitely not pointing at the +x direction, which is what we're looking at now, completely black, because the light's coming from the exact opposite side. So that's directional light. It's all coming from this looking at the -x direction. It doesn't have a particular origin. It's just anything that's in the -x direction is getting this green light. Okay, so that's our directional light. Let's just illustrate this point one more time. Let's change the direction. Let's say that we want to be looking in the negative, let's say positive y direction. Okay, I'm going to click. Now let's see. Aha. All right, so now we are looking into the positive y direction, which is down. And if we look at the negative y direction, completely black, because that's the other side of, opposite side of the light source. So we're looking down and positive. Now you can imagine combining these. So maybe our light is pointing both in the positive y direction and the -x direction. Let's see what the result of that is. All right, now I click, and now I can see that we're shining light both into the -x direction, like the first example, and the positive y direction. So this is how you can really start to control your scene by which direction your lights are pointing into. But again, we're not getting anything for the other directions. Nice. Okay, cool. All right, so that is our directional light. Now let's get into the complicated one, our spotlight. So to make a spotlight, we need to have the color as before. So let's make it a blue light this time, RGB. Okay. Comma. And I'm only putting space here just to help organize the different components of the light. You don't need to do that, but it just sometimes helps to separate them out a little bit. Okay, so now we need a location for the origin of our spotlight. So let's say that we want our spotlight to start all the way over on the right, so 400 pixels in the X direction, and then 0 in the Y and the Z direction. Now, if our spotlight is all the way in the positive X direction, maybe it makes sense for us to shine it towards the negative X direction. So we'll say negative X, 0, 0. Okay. Now it's that part about the rotation, which I told you kind of skim over briefly. Let's just put in something arbitrary. How about 90 degrees? And finally, we need the actually more important attribute, which is the how wide do we want our spotlight to be. So let's put in 10 and just see what that gives us. We'll change that in a second. Okay, clicking. All right, so now we have this blue light. So one thing you should notice is that unlike the directional light, not everything in this direction is being lit up, right? There's a bunch of hands that are further out from the center that aren't getting as much light. And that is because now that our spotlight has an actual location in space that it's starting from, and it has a certain width of the light, the diameter of it, that is going to hit more or less objects depending on how big it is. So let's try it this way. Let's put in, instead of 10, we're going to put in 1 for the size of the spotlight. So try to remember this. We had a couple of the hands around the center getting lighting. So let's put in 1 just to see what we get. Okay. All right, so if you can remember from the last time we ran this, we're actually seeing a lot more light on the hands that are further out. So maybe counterintuitively, by decreasing the number for the how big our spotlight is, it actually got bigger. If you are maybe into photography or something, you could kind of think about this with like aperture. So oddly, the larger the number is actually how smaller the spotlight will be, and the lower the number, the bigger the spotlight. Because right now we're basically back to our directional light, but when we had it as 10 instead of 1, we had decreased the size of that spotlight by quite a bit. Okay, just as one last example with this, I just want to see what happens when we put in something much bigger, like 75. And apologies for the slowness of my computer with the screen recording going. Okay, interesting. Now we almost can barely see that we're getting a little bit of blue light on the cube, on the icebox, but really nothing else. And that's because this much bigger number has decreased the spotlight by quite a bit. Okay. All right, so that's the spotlight. We needs color location, we'll say, how about origin, direction, rotation, this one's the complicated one, and finally size of spot, let's call it that. Okay, great. Now let's get back to one that's a little bit more reasonable. That's going to be our point light. So point light, let me comment out our spotlight. Point light. So all we need for point light is the color. Let's go back to red. And the location. So let's say that our point light is going to be -200 in x and 0 in the other directions. So we just need color and origin. So it's like your floor lamp in 3D space. Let's see what we get. Okay, and I click. All right, interesting. So what we can see is that to the left side, the -x side of our scene, we are getting some red light. But we'll notice that it's not like the directional light where, you know, if it was the directional light, we'd see a bunch of light from this angle, but we'd see like no light from this angle. But we're still seeing some redness from all sides. And that's because, you know, maybe right in here is maybe something like -200. That's the origin of our point light. Let's get a little bit closer. And it's kind of shining in all directions from that point. So this is like a good way, like maybe you want to have, you could have a, you know, a handful of point lights spread out through your scene that are maybe all giving off a different color, and you could start mixing them that way. In fact, let's try something like that. Let's say that we want another point light. Let's make this one green. 255. And let's say this one is going to be -150, and we'll keep it 0, 0. So now we just added another point light pretty close to that one. Let's see what we got. Okay, cool. So drawing on a little bit of color theory here, we have made kind of a yellowish light. So that's also something to remember, is that you can combine lights to get different colors. And we see that we're still locating this light to the -x side of things, but we're also seeing a little bit of variation based on where objects are. You know, some of them are getting a bit more of the red light, some of them are getting a bit more of the green light. Yeah, so you can play around with that quite a bit. Okay, let's just do one last thing with lighting and we'll be done for the day. I'm gonna comment this out. Great. So what I want to do is make light that's changing on its own, just to give you like a really kind of somewhat lame but and basic idea of how you could be having light change on its own without needing to do some kind of interaction. So I'm just gonna do this up here. I'm gonna make an int for our color R. So this will be for red. Let's make that 255. And let's make, how about our blue, color B, we'll start that at 0. So what we're gonna do is I'm gonna make a loop. Well, actually I don't even need a loop. I'm gonna put this in the draw section. What I'm gonna do is I'm gonna change our color R and color B, and then have a conditional to reset them when they go outside of the color range. But let's just see what this looks like. So what I wanna do is I wanna say as our draw loop goes, I want to decrease the amount of red. Because remember, it started at 255, so I want to decrease the amount of red. And then, but if our red gets less than 0, probably guess where I'm going with this, right? I want to reset that back to 255. So then color red will go back to 255. Reset to 255. And now we're just going to do the same thing, kind of the opposite though, with our blue color. So blue started at 0 in this example, so I'm going to increase it. Increase amount of blue. However, when blue gets bigger than 255, greater than 255, we are going to reset it back to 0. Color B equals 0. And finally, let's just actually use this light. Let's just use an ambient light. So we're going to say ambient light color R. Why don't we put some random number for G, and then color B. And let's just see what we get finally here. Okay, and now we can see that the ambient light of our scene is slowly modulating based on our color R and color B getting bigger and smaller and then getting reset. So you can imagine a much more interesting scenario where maybe there's a whole array of lights that are changing. Maybe the light is changing based on the rotation of the entire scene or something like that. But you can kind of take it away from there for your own 3D scene for the assignment. All right, folks, so that's all we have for our 3 lectures on 3D environments. Your assignment is on the website, and you can use any of these elements, or you can kind of go in your own direction. And I'm excited to see what you all cook up. All right, we'll see you next time. All done.